Hello geometry students, and welcome to another day where we're going to be talking about surface area. You'll notice that it is a new section, 10.5. The past 2 days we've been working on 10.4, which was prisms, and let's see if I have one, a cylinder. So that's what we've been working on, are these two shapes where they have the two bases. They have multiple faces, but they have two bases. And 10.5 is about shapes that have one base, and one of those shapes would be a pyramid. And so we're going to be talking about the surface area of pyramids today. Can I find the surface area of a regular pyramid? Regular meaning the base is a regular shape. And what does regular mean? It means all of the sides are the same, all of the angles are the same. So when I have something like a regular quadrilateral, well, that's a square. But if I have, what do I have here? Oh, like a regular pentagon has all the same sides and all the same angles. So when we're talking about pyramids today and we look at surface area of pyramids and we look at volume of pyramids, we are only able to use a formula for a regular pyramid. So let's write down the surface area formula for a regular pyramid. That's what we're going to use today. So let me write that down for us. You can use the one in your formula sheet. You can get it offline. If you looked up what's the surface area of a pyramid, you probably would find this on there. But let's put it in your notes no matter what. So 1/2 P, that's a cursive L. And that cursive L stands for slant height. And we'll talk about that in a minute. And then big B, just like when we looked at our prisms and our cylinders, we had a big B, and that big B was area of the base. We are going to have one base. So instead of two bases, like a prism has, a regular pyramid only has one base. So we are going to do our best to sketch or to draw. So why don't you do this with me if you need to take a second to do it. I'm going to draw a quadrilateral regular pyramid, or a square pyramid where the base is square. And we're going to draw it like as if we were looking at it, kind of like that. So that's what we're going to draw. So start by drawing a triangle. I've done it there. Decide, I'm going to go back, I don't know if you want to call that like a 30-degree angle or something. And then you're going to do the other one in a dashed line. Probably not the best one we could have done, but we're going to pretend. Okay, yeah, this isn't going to look great, but that's fine. That's totally fine. If the front one is horizontal, the back one's going to be horizontal, and then just kind of connect it down there. So we're going to pretend that that is a fantastic pyramid, even though it doesn't really look like it. That's all right. And we're going to piece this all together. So I'm going to use maybe 2 colors, 3 colors maybe. Yeah, 2. Okay. When I talk about the perimeter of the base, that big P stands for perimeter of the base. Hopefully you remember that. That's a perimeter of the base. The big B, as we've used recently, that is your area of the base. And that L is our new, is the new unknown thing. And I'm going to show you what the L is. I'm going to show you on the little diagram here. This is a triangular pyramid, but that's okay. So L is actually the slant height. It is from the tip top, or the one vertex that's opposite the base, and it goes directly down the side. And I totally forgot to add this. I'll add it now. There is a 90-degree angle between the slant height, that L stands for slant height, and the base. So the slant height is because it's on a slant. It's not 90 degree to the ground, or I'm sorry, like perfectly perpendicular to the ground, but it's perpendicular to the edge here. So on our slant height, you will know that it's slant height if it goes from the, what color should I use? I'll use red because you can see that. It goes from this vertex and it goes all the way down. And if it stops before it hits the edge, it might not be the slant height. So in that case is our slant height. And that's the new thing that we really got to know what we're talking about, because there will be a slant height when we're talking about cones too. So we got to know what that slant height is. So let's look at some examples. I have 2 examples for you today that we're going to do together. And I had it all ready. Okay. So here is example 1. I am going to draw these with you, but if you feel like you need to just like kind of sketch it out and do your best later, that's fine. If you want to pause the video after I sketch it to draw it, that's totally okay too. So I'm going to draw a square pyramid like we did before. I'm going to kind of follow the same rules I had, but I might just, I don't know, make it a little bit neater. We'll see how this ends up. Okay, not horrible. I think I'm learning along with you guys. Normally these would be printed on your packet, but you're learning so much. Okay, so here is our square pyramid. I'm telling you it's a square pyramid, otherwise it would either be written or the sides would be marked. But if it's a regular pyramid, it would have to be square. If it has 4 sides, I'm going to write out the surface area formula. I am going to request, ask, suggest, whatever to you to write that out. Because then you will know when you're finding all of these pieces what to plug in where. And that will make your life a lot easier. So if you even just set all of this up, because then most of it you can just find by looking at it. So this is what's given to you. This is 5 centimeters. And this slant height right here is 9 centimeters. So clearly not drawn to scale, but those are the 2 measurements that we have. So let's look and see what we've got. I'm going to use the same colors I did before. So my perimeter is all around the base there. If the side length is 5, the perimeter is 20. What is my slant height? My slant height's given. That will almost always be given. You can probably bank on it that it's going to be given to you. And then lastly, our base. And again, we wouldn't be able to do this necessarily if we didn't know this was a regular pyramid. But because we know it's regular, if it's regular, it's going to be all the sides are the same. And if it's all the sides that are the same, it's 5 times 5, which is 25. And guess what? At this point, plug it all in your calculator. Plug that all in your calculator. 1/2, 0.5 times 20, that's 10. So 9 is 90, plus 25 is 115. Did we say centimeters? Centimeters squared. That is how you use the area formula for a pyramid when everything is given to you that you need. We're going to do one more example where you have to do a little bit more work to find the base, for example. So almost everything you need is given, but you just have to do a little bit more work, for example, to find the area of the base. Just like how you would have to if there was like a pentagon on the base. You would have to find the apothem, find the area, and then use that area for your formula. We are going to draw a triangular pyramid. The best way to do that is to make this first little triangle a little slanty. And again, because this is a regular pyramid, you kind of want all the sides to be the same length. So I'm going to put it like back there. And those 2 sides. And there's a back side that I can't see. Okay, not horrible. If you guys know one thing about me is that I'm really bad at long division and 3D shapes. So I think I'm getting better at it. Awesome. Let's see what is given to you. This is a regular pyramid, meaning the base is regular, meaning the base is equilateral. So this is 10 centimeters, and this slant height, I know it's the slant height because it goes all the way down to the edge. If you ever saw something like this, which you totally could at some point, like this, and it went to the center, that would be the height. That would be like if I said, let's look at this from the side. If I said, okay, what is from the very bottom or from this top all the way down to the bottom or the center of the shape, that would be the height. But the slant height or the slant length is from here slanted versus from here straight down. So we're going to talk about the slant height. Okay, so the slant height is 8. Now let's figure out everything we need to know. So write out our surface area formula. Oh, there we go. Our surface area formula is 1/2 perimeter slant height plus the base. I think it's helpful to write it out. I can't make you guys do it because I'm not there, but that's what I'd be doing if I was there. What's given to us? Ooh, slant height. Easy. Awesome. Yes. Slant height is 9. 8. I don't know why I said 9. It is 8. The perimeter, super awesome, is 30 because it is a regular pyramid, meaning all the sides are the same. So that is 30. And the last thing we need to know is the area of the base. I'm going to draw the triangle out here because that will help us find the area of the triangle a little bit better. So I don't know the height of the triangle. I know that this is 10. I know that that's 10. I know that that's 10. I know it's a 60, 60, 60 triangle. So I'm hoping at this point you're going, oh, I know how to find the area of this. There's a few ways of doing it. No matter what you do, you got to do that. So what could we do? What I'm going to do is I'm going to use the Pythagorean theorem for that triangle right here. And say if this is 10 and this is 5, what is my height? So there's a little triangle here that's a 10 and a 5 and an x, and I'm going to set up the Pythagorean theorem to find out what that x value is. You are hopefully like decades ahead of me with this, but I'm going to go really slow. So the height of this triangle is the square root of 75. So if I was looking for the area of the base, or I'll even put a big B because that stands for area of the base, it's 1/2 10 times the square root of 75. Plug that all in your calculator, and you get 43.301. That is the area of the base. 43.301. Plug that all in your calculator. Add that all up. 15 times 8, or I said 15, but it's 1/2 of 30, times 8 plus 43.301. I'm going to round to the nearest tenth, and our answer would be 163.3 centimeters if I would have put centimeters over here for 8, which I meant to do. Centimeters squared, because it's area. So hopefully those two examples will help you when you are finding the surface area of pyramids, and we're going to work on cones on Friday.